Good morning, good afternoon, and good evening, ladies and gentlemen. Thank you for joining us on our webinar today. This particular webinar is entitled DNS for Business Managers, What Every Manager Needs to Know. And I think it's fair to say that the domain name system is a mystery to most business managers. However, I think one thing is absolutely clear, that without the DNS, your websites will not work. And so also even a few seconds of DNS downtime or outage can actually cost some companies millions of dollars in revenue, as well as affecting consumer confidence. So this 40-minute keynote webinar will be discussing the basics about DNS and also why business managers can actually benefit from understanding just a little bit more about it. In terms of a few words on housekeeping now, if you have any questions, please type them into the chat window at the bottom, and our speakers will respond to them at the end of the presentation if we have time. After the presentation, we'll send a link to all participants so that you can review the presentation again or forward it to your colleagues. Your presenters today will be Tom Webb. Welcome, Tom. Tom is the Group Product Manager for Brand Services and joined CentralNic after being head of product for a few big corporate domain name registrars, NetNames and CSC Global. Tom has over 13 years experience as a senior product manager and extensive experience with domain names, brand protection, DNS and security. I will be your second presenter today. I manage marketing for CentralNic Brand Services, and I've been working in the domain name industry for nearly 15 years. I have held positions in both marketing and product for registry operators and registrars. In product roles, I've developed online registrar and registry systems for a number of companies, including brand protection systems and DNS infrastructure. So if I can introduce Tom now. Tom, if you can turn your camera on. And I will hand over the mic to you, and so please take it away.
Great, thanks, Andy. So my task today is to give you an overview of what exactly is DNS, try and demystify a lot of the technological side of it and just put it into the real world of what it means, and then talk through some of the things that can affect or can be done to your DNS to interrupt how your customers get to your internet infrastructure. So I'm going to take you through some really high-level stuff here, but every device that is connected to the internet, be it a home or office computer, your mobile phone, or all of your websites and infrastructure, they all have what is called an IP address. This is a number, so typically 4 numbers, and this is the location on the internet where that device is. And in order for any device to communicate with another device, so a laptop to connect to a website, it needs to know that address. And you can think of it sort of like a telephone number. In order to phone someone, you need to know their telephone number. It's no good just knowing their name. You need to know exactly what the number is in order to connect to them. That is no different to the internet. Those IP addresses help you route traffic across the internet so that one computer or laptop can connect to another. Now, you're all probably very aware that we don't use these numbers in day-to-day usage. You don't actually type any of these numbers in to work on the internet. Some of you might from the past remember your best friend's telephone number, but very much the world has moved on. And in domain names, that is true too. What we have is a domain name system. Now, the domain name system is there to translate, to create word associations with those IP addresses. So you can think of the domain name system as just a really big phone book. And the phone book is there to take the name of something and translate it into a number. And the DNS is no different to that. So we have domain names. So for example, centralnic.com. And we have the domain name system that translates that into the IP address. This allows then computers to communicate over the internet. Now, this provides two major benefits. Firstly, as humans, we're not great at remembering numbers. So remembering words is much easier for us. So remembering a website address as a word is much easier than a telephone number. But secondly, it disassociates the address from the name. So should a device move or change its IP address, you don't have to remember a complete new number. You just have to remember the domain name. And should that number change, and you don't need to worry about it, the systems behind it will figure out the new number. So how does this practically work? So when someone wants to go to a website, for example, they want to go to shop.acmelimited.com, when the user types that into their browser, they have absolutely no idea where to go to get that information. Much like if you want to phone up a business and you don't know the telephone number, you don't really know where to start. Well, the same is true on the internet. But the first step is to go off to the DNS system. Now, the DNS system will take that address and respond to the computer with an IP address. Very much similar to going to a phone book and looking up the telephone number of the business. That address is given back to the computer. Now the computer knows where to go to find the website, and it can connect to that website. So it's a two-step transaction, really. So it's going from the computer to the DNS system. It gets the location and then can connect. Now, hopefully what you can see within here is that this becomes a very critical part of the internet infrastructure, because should anything happen to that DNS lookup and it doesn't respond with where the website is, that website might as well not be on the internet. So should anything happen to your DNS system, your users will not be able to find your online assets. And this is why the DNS is such a critical part of the internet infrastructure. And it's a thing often overlooked by a lot of business managers, is the importance of DNS within their online presence. Now, how it actually works is a little bit more complicated than that. And still, this is a relatively high-level overview, but when a computer is trying to get to its destination, it actually goes through a number of different steps. And it's important to know these different steps just to see how you can affect what's going on. So to that same example, if someone is trying to get from the computer to your online services, they actually go through a four-step process. The first step is when you type in the web address, they have absolutely no idea where to go whatsoever. So there is a place called the root name servers. Now, these root name servers are run by ICANN, the general group that looks after the domain name system. There are 13 of these name servers dotted around the world. And the first place, if you don't know where to go, is to those root name servers. Now, those root name servers will read the address that you put in. So in this case, say acmelimited.com, and it will recognize that you are looking for something in the .com namespace. So it tells you where to go to find out information about .com. So it redirects you to the second point here, which is the .com registry's name server. That is run by a registry. The particular .com is run by VeriSign, but there are many TLDs, you probably know, .co.uk, .de, and others around the world. Those are all registries, and that's where domain names are registered. The computer there asks that name server, can you tell me where the acmelimited.com name server is? And that registry will respond to the computer and say, it's over here. So that's when you move to step 3. Now, your name server is under your control. So either you have it within your own infrastructure or you've outsourced that to a third party. On there, that's where the final transaction takes place and the IP address of the website is found and returned to the customer, and then they connect to the online premises. Now, obviously, you don't have any control over the first step. That's the root name servers. But you know, the internet is a very popular thing, so those are very secure and looked after critically across the internet. The second level, the TLDs, you do have some level of control over which TLDs are part of your infrastructure, because you get to choose where you register your domain names. Now, obviously, .com is one of the most popular. It has millions of domain names on it. You can be pretty confident that the name system there is very robust. But there are others that aren't quite so robust. Some country code TLDs don't necessarily have the finances to put on a great DNS infrastructure. An example of this is, you know, there are some like people who like to shorten domain names. And there's an example of a company that had a .nr domain name for all of their social media because it shortened their name very well. But .nr is Nauru, which is a Oceania country just off Australia, and they don't really invest that amount of money into their name server infrastructure. So when that name server went down, it took down all of their social media posts. The third one, the name servers that are under your control, now you can choose to host those yourselves, or you can outsource those to a third party. Most people outsource that to a third party to do that because it's just the cost scales of that and the performance you can get benefits from doing that. But that is under your control, and it is something you need to take seriously as part of your internet infrastructure. Why do you need to take this seriously? Well, there are threats. As I said earlier, the DNS is really important to finding where you are on the internet. So any interruption to that can interrupt your appearance on the internet. And there are, unfortunately, cyber criminals who are more than happy to hold to ransom companies by taking out their DNS infrastructure. Now, I'm going to talk about two of the main ways that they do that. One is through availability attacks, and the second way is through integrity attacks. So an availability attack is really trying to take out the name server so it can't respond to the questions being asked by computers on the internet. This is what's known as a DDoS attack. So you might have heard of DDoS. The acronym means Distributed Denial of Service. So what effectively is trying to be done here is to take out the name server by denying it from being able to respond properly. Now, under normal operations, a DNS server will get a question like, what is this domain name's IP address? And it will respond, and it can do that happily millions of times a second, all days of the year. Under a DDoS attack, what happens is that a malicious user sends so many requests so fast to that one server that it has trouble keeping up in responding, and either slows down responses to real questions or overheats and breaks down and falls off the edge of the world. And in that scenario, if that occurs, none of the valid questions are being answered, no one is getting your IP address, no one can find your website. Now, the prevalence of DDoS attacks is increasing and has been increasing as the internet has evolved, and they are used as a tool to take off online services and affect the companies behind them. You've probably heard about many DDoS attacks or been affected by them when services have gone offline. There are things you can do about those types of attacks. The first thing is to put some DDoS protection in front of it or having huge capacity. If you are able to answer trillions of questions per second, then you are not going to be affected by those questions that don't mean anything as part of an attack. If you can answer everything that comes in, regardless of whether it is valid or an attack, then no one knows any different. The other thing to do is look for the problems and start mitigating against them. So you might find that all of this malicious traffic is coming from one location, and you just say, well, I'm going to ignore everything that comes from that location, and everyone else will be fine. Secondly, you want to make sure that you've got a globally distributed network. One of the other things is most attacks might be sent from a single location. Some of them might be more distributed than that. So being globally distributed allows good performance around the world. And thirdly, you want to make sure that your DNS is monitored all the time, 24/7, with high levels of DNS expertise to be able to identify and mitigate those attacks that might come in and keep your DNS services running. And the second type of attack is an integrity attack. So rather than trying to take your DNS servers offline and therefore not available and not being able to find your premises, what they might want to do as a cyber criminal is redirect the traffic somewhere else. Because obviously the domain name system is translating a name into an IP address. If you could interrupt that and give a different IP address to what should be there, then you can redirect traffic somewhere else. Now, this might be done as a way to do some kind of phishing crime, so create a replica of the website, redirect traffic to it, and then capture details through doing that. Or it might be just to be able to listen into valid traffic to capture details that go over it. Now, these are very pernicious attacks. They're not things that you want to have happening, and typically take place by taking over your DNS infrastructure or infiltrating your DNS infrastructure and changing the settings within it. So it's really important when it comes to those types of attacks that you put in the protections against that. So some of the things you can do to protect against integrity attacks is make sure you use DNS security, or DNS-sec as it's known, and also use a provider that has got robust security provisioning around the DNS infrastructure. To put it into the kind of real world, what does this mean for you? Well, DNS attacks have a real world cost to businesses. Most businesses online have experienced attack. Whether you've noticed it or not is a different thing, but most popular internet infrastructure will have received an attack. And in a survey that was done, around 80% of businesses have experienced an attack. The average number of attacks per company is around 9.5 per year. And then there's the cost element to it. And the best way to think about the cost element is like how much money is transacted through your web infrastructure. So that could be how much do you transact with your customers, or how much do your customers transact over your infrastructure that you support. And again, another survey had itemized that the average cost of an attack for the downtime and the impact on those transactions is around $1 million. And the really critical thing is the loss of applications. So 82% have seen some level of downtime, either wholly or in part of their web infrastructure. And that's contributes to the financial loss, but also to the perception of the brand and the integrity of that. So that's why DNS is so important. So when thinking about DNS within your infrastructure, it's really important to query and make sure that your technical teams have thought about these 5 main things. So firstly, does your DNS infrastructure have a high query volume capacity? Can it deal with you suddenly becoming popular, but also deal with large attacks that might come your way? Secondly, you want to make sure your DNS is fast. It is part of the steps between your customer getting from their computer to your web infrastructure. So it has an impact on the time it takes for people to get to your website. So having a slow DNS system is going to impact your user experience. So you want to make sure that you have a fast set of infrastructure. Thirdly, you want to make sure it's really robust, always available, not going to drop out, not going to not respond. So it's important that you have that. It needs to be secure. You need to make sure that no one can infiltrate your DNS networks. No one can change what it is, that the appropriate people have the right permissions to get onto that. And finally, you want to make sure it's maintainable. You need to be able to maintain your DNS infrastructure so that you can do the things that you want to do. So that's an overview of the DNS system. I hope I've put that in a way to kind of highlight and change the kind of real techie stuff into something you can understand, and then just take you through some of the challenges that might exist within the DNS infrastructure. So now I'm going to hand back over to Andy, who's going to take you through some other information that you need to know.
Thanks, Tom. That was an excellent overview for, I think, for the business manager, not too technical. And I think if for a business manager to take one key thing away, that the DNS is basically like a large phone book translating people's names into numbers that can be read by a machine. So when it comes to looking at the DNS from a business manager's point of view, I would kind of say, well, forget about all that lovely techie stuff, because it's very easy to be pulled down the rabbit warren of a technical nonsense, really, that goes to make up the DNS. It's all incredibly useful, it's all incredibly relevant, but actually it's very technical, and ultimately the DNS is there to move an internet user onto your website, and that's the key thing. So ignore all the fancy but confusing technology, and what do we have left? What we have is an enormous list of every direction request from every internet user on the planet, 24/7, every day of the week. So this is who is asking to go to what website and when, and how are they actually asking to get there. So if we have all this information available to us, why isn't it, as a business manager, that I've actually heard of using DNS data before? Well, DNS data has been around for a long time, ever since the beginning of the internet, and it's long been recognized as potentially an incredible source of market intelligence. The problem is that the sheer volume of data available has been an impediment, not the fact that we have that data to hand, but because actually analyzing that amount of data is incredibly complicated. And so the recent revolution in data analysis and machine learning, coupled with AI, actually has started to allow us to extract valuable insights from the DNS. However, before we launch down this route of using DNS data, it's worth understanding that actually there are a number of challenges involved in analyzing the DNS. It's estimated that there are something like 8 trillion DNS queries a day. And the reason why I say it's estimated is because there are actually many hundreds, probably thousands of DNS servers around the world, and they're not necessarily all connected together in a way that we can aggregate the data from them and interrogate it in a single unified manner. So there are many dozens of DNS providers, both commercial, public, and also corporate. So it's not unusual for, as Tom was saying, a business to operate its own DNS infrastructure at the very end of that DNS tree. And commercial operators may not be keen on sharing their own DNS data. So there are many dozens of network providers, many private DNS networks available. And so this is why we can only really estimate the number of DNS queries that happen a day. But as you can see, it's a big number, and it's been growing very rapidly over the last few years. There were about 2 trillion queries a day in 2016, so we've quadrupled that over the last 4 years. And that means a lot of good things and some bad things. First of all, the good things is obviously there's a lot more data that can be analyzed, which means it can give you a lot more insights. The bad thing is it takes a lot more time and effort and computing power to analyze those queries. So another challenge of analyzing the DNS is that currently we just don't have a way of aggregating data from all providers. We do have ways of aggregating certain data from certain providers, but we certainly can't cover the entirety of the globe. And then finally, you do need a rather powerful computing setup to analyze these data sets that are just so huge. So a number of challenges, all of which are getting easier to deal with year on year as computer power goes up. And our systems for big data analysis and things like artificial intelligence can help us in making sense of such large data sets. So the DNS data, which we've identified as being potentially very valuable from a marketing and threat intelligence point of view, is now actually starting to be used in anger to drive business decisions. There are a number of different things that the DNS data can be used for. What I'm doing here today is just focusing on 2 of them. And you'll see quite a lot of this, these decision makings are driven by inference from what the DNS data is implying, rather than absolute go, no-go decisions. You have to interpret the data and make a decision based upon them. So we're inferring activity from the data that is being provided. If we take a look first at threat intelligence, as Tom was saying earlier, it's important to ensure that the DNS remains up and is protected so that your websites are always available. And one of the ways that you can do this is to actually start to look at what is happening in the DNS, what queries are being sent, where they're being routed, that kind of thing, to actually give you an early insight of different types of attack that either at the beginning of being launched or are considering being launched, so that you can protect against them. Typical types of attack identify things like online fraud, phishing, data loss, things like domain takeover, where you're actually hijacking a domain and you're pointing it somewhere else, and delivery of malware. This is in addition to the most common form of attack, which is distributed denial of service, whose aim is purely to flood your network and stop other people reaching the websites that they're trying to get to. So if we take a look at phishing protection, if you look at the anatomy of a phishing attack, without getting into too many complex details, basically what will happen is in the first 24 to 36 hours is where the phishing attack does its most damage. It's before the fraud prevention systems have caught up with it. They've started to blacklist those URLs. They've taken down the websites, etc. So the first 24 to 36 hours are the most crucial in terms of damage on a phishing attack. So what you can do with the DNS is you can monitor newly published or newly observed domains. You route that into your security ecosystem and you keep monitoring it. You can look at what is happening on the websites as they're being developed, or the domain name as it's being developed. For example, does it have an SSL certificate on it? Does it have a website on it? Does it have email enabled on it? All of these things can start to give you an insight as to whether or not a phishing attack is likely to be launched from a suspect domain name. And so what you can then do is just block access to all these newly registered and suspect domain names for a period of time, which will then hopefully get you over this hump of 24 to 36 hours of what they call the golden hours for phishing attack, which is where the data, where most people fall victim to it. And so then you can, after that period of time, you can enable access to the domain, and the threat intelligence data that you've gathered enables you to continue to block potential phishing sites or high-risk phishing sites. So using DNS-based threat feeds can help you in a number of ways. And typically a DNS-based threat feed will come from multiple sources. So if you remember, I said there are many dozens of DNS providers, commercial DNS providers. There are also very large corporations, the likes of Microsoft and Google, etc., that operate their own DNSs. And they can actually provide a threat intelligence feed on what is happening on their networks. When you can start to aggregate those together and interrogate those feeds in real time, then it can help you with things like preventative blocking and ensuring better defense against things like phishing attacks. It can help you reduce the mean time to detection because you're getting these feeds from multiple places in real time. And it can also help you reduce the time taken to actually counter those attacks because you're getting early feeds and you're getting reinforcement from multiple different feeds to allow you to identify what you think is a suspect domain name that could be the source of an attack, and it can then also allow you to take immediate action before it starts to become a real issue for you. And then thirdly, you can reduce false positives. If you're being told that a domain name is suspect from one provider, that's one thing. But if you're being told the same thing from multiple sources, all of whom you trust, that gives you a much better idea of what may be a false positive and what may be an actual threat to your network and your domain names. So by aggregating these DNS threat feeds, we can actually start to prevent DNS attacks on the internet, and protect your customers, protect your own assets, and ensure that the outcome of an attack is much less damaging than maybe it would have been should you not have this intelligence early on. The second thing we can take a look at is DNS for marketing intelligence. Now, this is something that's coming out and is being used still, I'd say, at a fairly high level at this stage, but you can use DNS query data to give you an idea of market trends, as well as how you stack up against competitors, etc. So you can excuse me, interrogate the DNS to find out how popular your websites are by looking at how many requests you get to go to your sites. But of course, with the DNS, you're not restricted to only being able to look at what's happening on your website. You can have a look and see what's happening in terms of requests to your competitors' websites. So you can start to get comparative data that you can then start to use from a marketing intelligence point of view. You can start to get data about where those DNS requests are coming from. The DNS has a very loose affiliation of networked computers all around the world, and one DNS property, which is commonly known as GeoDNS, will route a DNS request from somebody, for example, in Malaysia, to a server that is in Malaysia, in order to reduce the latency and ensure that they get served their pages, their websites, as fast as possible. So we can start to use that network and the geographic locations of these IP addresses to identify who is looking for what and from where, as well as what time they're looking at it. So you can start to build up a picture of popularity. How do you use this from a marketing intelligence point of view? Well, if you do things like use paid search advertising, you can start to target and ramp up your activity on, say, Google AdWords to meet with the surge in demand that you're getting from particular places. So you can start to cross-correlate these sorts of things in order to maximize the exposure of your brands on paid advertising placements at the right time. So all of these sorts of things you can use to infer behavioral activities, and then match your marketing to take the most advantage of that. And then you can also use it to detect trends. So you can start to look at what language is being used. Are people looking for website versus web page, for example? And again, when it comes to registering domain names that may have these key terms in them, you can start to use that to try and maximize the likelihood of your website being the one that is landed upon. You can look at the languages that are actually being used and the time that they're being used. So, for example, you have hotels in English, but you have hoteles in Spanish. Looking at those DNS queries can give you an indication of where, not only where, but what language is being used to search for or to access DNS queries. You can also take a look at popular terms. So language is a constantly changing thing. So, how many people now just use the word selfie in place of using the word pic, for example? These are the sorts of trends that you can use to then start to register domain names that will also perform better from those DNS queries. And finally, you can look at, as I said, language is changing, and it's also very colloquial. It's less formal than it used to be, and so we start to use colloquial terms on the internet. So, for example, instead of the word fashionable, my teenage daughter would probably have used the word snatch. Okay, so these are trends in language that again can give us a little bit of an edge when it comes to increasing the traffic that lands upon your websites. Then looking at what requests actually aren't being fulfilled. Now this is actually as important as looking at the requests and what is happening for DNS requests that are being fulfilled. These things are known as NX domain data. So when you send a request for a website that doesn't exist, you will get a report that says this website isn't available. And in the next slide, we'll take a look at what you can do with that information. It's quite relevant. You can also look at competitor intelligence as well. So quite often, companies will set up their own web infrastructure to reflect their customers. So they might use a subdomain to allow access to certain customers that they've just signed up. All of this can give you some very valuable competitor intelligence as to the customers and where what your competitors have in terms of customers and partners, and also if they're planning to launch new products as well. You can start to look and see whether or not they've registered domain names and they're using websites to get ready to promote those domain names. So when it comes to using NX data from the DNS, this is quite an interesting area to look at. And you can see on the right-hand side with the pictures there, these are the sorts of, if you type in a domain name that doesn't exist, this is the sort of thing you'll get in response, typically. And this is known as an NX domain error. But understanding which NX domain is being queried is actually very valuable, because that means that the domain name that is being looked for, that is being hunted for, doesn't actually exist. This is not that a 404 error. This is saying that the domain that you're after doesn't exist, so the domain name has not been registered. And by knowing this and looking at the number of queries that for the same sorts of terms that are not being resolved, can actually allow you to register popular but non-existing domain names and drive traffic to your websites that way. It's important to note that actually some registries provide NX domain query data free of charge, or will allow you to interrogate their NX database. The reason for that is because corporates that are using this NX data are likely to register domain names based upon the NX data query data that they're interrogating. And that will obviously add more domain names into the registry. So it's kind of a win-win. It's also worth noting that there are some top-level domains that automatically redirect all NX domains to a specific web page. So rather than turning up the error page that you've seen on the right, what it will do is will redirect you to a page under its control that may, for example, provide low-cost but advertising placements on it. Knowing this can allow you to maximize your advertising spend and the return on your advertising spend. So, as I was saying earlier, knowing which domain queries are not fulfilled is often as valuable as knowing which ones do get fulfilled. So, in summary, I think it's fair to say that the DNS is quite often an overlooked business-critical part of your infrastructure. It's there to ensure that your websites are reachable at all times, and therefore considering A high specification DNS with a good DDoS protection, etc., is a very worthwhile thing to do. It's a very beneficial expense to ensure that your websites are available at all times, and that response times are not slowed down because you have either an outdated or a rather shaky DNS network. The other thing to note is that cyber criminals regularly attack the DNS, trying to take your services offline. This is either done by organized criminal gangs, sometimes nation state attacks have been known to happen through the DNS, as well as script kiddies who basically download an app onto their computer, network together, and run a script that launches a DDoS attack, for example. And when we're looking at DNS intelligence, the data that is held within the DNS and can provide incredible business information if you take the time to aggregate your feeds, gather your data, and interrogate that information intelligently. It can deliver early warnings of potential attacks, which can mitigate those attacks or certainly reduce the damage that those attacks cause. And it can help you identify commercial trends, revisit the use of language in your domain names and keyword domain names and things like that to help you maximize the traffic that comes across your websites. So with that, we've had a few questions in. I'd like to thank you, Tom, for rejoining. Before we launch into the questions, I'd like to draw your attention to our next webinar, which is on the 15th of April, hosted by me again, where we will invite some experts to discuss domain name strategy and how businesses can use a robust strategy to minimize their cost, but also maximize the impact of their domain budgets. If you have any further questions or want to contact either Tom or I, outside of that, our email addresses are in the top left there. I will finally, I'll launch in. We've had 4 questions in. So I'm conscious that we're actually running up to time on our webinar now, but we'll try and answer these fairly expeditiously. Tom, if I can ask you this one first. It says, can I control and own my own DNS infrastructure?
Yes, it's perfectly possible. The internet is obviously open to anyone to run any servers that they want on it. So if you want to run your own DNS servers, you can, and some people do that themselves. The thing I would just caution on is that the DNS is such an important part of it. You need to invest probably quite a lot into it to make sure it resolves as well as some of the corporate or some of the commercial deliveries of DNS. So it's really a cost-benefit analysis of doing that. But if you wanted to, there is open source software out there.
We've had, another question is, if a domain is not working, can you still see the website by searching for the IP address?
Yes, you can. So in that example earlier, where I put the IP address on the screen, that was actually a real IP address. So when the domain name system has gone down, it is possible to use the IP address. The only issue is that most people don't know what the IP address is or where to go and find that. And usually by the time they need to know that, the DNS system has gone down. So it is perfectly possible to access a website just using it. And you can try it out yourself. You can just type in an IP address and you'll find the website of the most common places. And it's quite, if you're geeky enough like me.
So another question that come in, which I'll field, is where can I get hold of DNS data? Well, that is quite a broad and complicated answer we can give to this. But in the broadest terms, I guess, and the simplest terms, there are commercial companies that take aggregated DNS feeds from multiple sources and will offer these feeds on a commercial basis. Secondly, there are commercial enterprise DNS providers, so the likes of companies such as Newstar, Akamai, Cloudflare, etc., who do provide extensive DNS networks for enterprises. Some of them also provide DNS data feeds. Typically, they use them for threat intelligence or security purposes, but they can be used for marketing intelligence as well. And then finally, I think I mentioned in the presentation, some registries are also prepared to provide their DNS data feeds, in particular their NX data feeds, have an interface where you can actually query their DNS to try and get statistics from it. And then, so Tom, how much does it typically cost to run DNS infrastructure in-house?
Well, it's a bit like how long is a piece of string, really. It depends how much you want to invest into it. You can think of it like any other kind of internet infrastructure. You can just have some single servers in some data center somewhere, or you might want to build something a bit more robust and distributed. So you've just got to think of it in lines of how many servers you'd want to have running. Typically more than one is, you need to have more than one, so probably at least 4 or 5 servers running. Then you have to think of the data center costs, the traffic costs over that. So that can rack up pretty quickly, and then you have the operational people to support it as well. So very quickly you can get to a cost point where it's not necessarily as competitive as taking a commercial partner's DNS services, where all of that is built into the scalability of it. But there are some organizations who want to have full control, so it is possible to do that, but I would say it can rack up into the hundreds of thousands of dollars quite quickly if you want to do something comparable to a robust
just actually as a comment on the question about if the DNS is down, can you type in your IP address and get to the website? Tom correctly said that you can do that. It's also worth noting, though, that some servers, which give you the IP address for the servers, will host multiple websites on them. So you need to know the structure of that web server in order to accurately get to the website that you want to get to.
Yeah, that is true. In the simplest form, an IP address will get you to the website. But yeah, there are a few hidden things in the way that websites.
But in principle, you can get to your websites using an IP address. And then the final question is, how do I advertise or get data on NX domains? Well, actually, the answer to that is very similar to the answer I gave to the last one on DNS data, where there are commercial companies that specialize in using the NX data to provide advertising networks. So you might consider companies like trafficclub.com. There are other providers as well, obviously. Again, some registries, if you remember, I mentioned that some registries actually automatically direct NX data to a particular website. Some registries actually operate commercial advertising on those sites. Although, again, I should say that you will probably be best to go to a specialist ad network provider, because they will probably already have those relationships set up. And then some registries are also prepared to share their NX data with third parties, often free of charge, just to help them actually sell more domain names. Some will only allow this through their registrars, but generally, you could approach a registry, for example, VeriSign, which operates .com, and they may, either on commercial terms or free of charge, allow you access to query their NX data records. Now that's it. We have no more questions. Hopefully we have answered all of your questions fully. If you have any more, please do feel free to send them to either us directly or to BrandShelter at brandprotection@brandshelter.com. And also please do sign up for our next webinar, which will be happening on the 15th of April at 3 p.m. GMT on domain strategy. Thank you very much for your attendance, and we certainly look forward to seeing you the next time. Thanks, Tom, and thanks, everybody.